scientists are calling it the most mysterious discovery of the decade. 3I Atlas, the massive interstellar visitor that shouldn't even exist, has just revealed a secret that's forcing astronomers to rewrite everything they thought they knew about objects from beyond our solar system. Racing through space at 60 kilometers per second, this alien wanderer carries within its ancient structure something that defies every model of how interstellar objects should behave. The James Webb Space Telescope. Its latest observations have detected anomalies so strange that Harvard researchers are asking uncomfortable questions about 3I Atlas's true nature. Is this really just a natural comet from another star system? Or have we been watching something far more extraordinary than anyone dared to imagine? The chemical signatures don't match. The trajectory seems too precise. The behavior patterns are unlike anything we've seen from natural cosmic objects. And now, new data suggests 3I Atlas might be carrying information, or even technology, from civilizations that existed billions of years before Earth formed. Tonight, as you drift into sleep, join us as we uncover the alien secrets hidden within the most enigmatic visitor our solar system has ever received. Subscribe to explore the universe's most profound mysteries and impossible discoveries. In the annals of astronomical discovery, certain objects arrive with such profound implications that they force humanity to reconsider its place in the cosmic hierarchy. 3I Atlas represents such a visitor, an interstellar wanderer whose very existence challenges fundamental assumptions about the nature of objects that travel between the stars, and whose recent revelations suggest we may be dealing with something far more extraordinary than a simple comet from another solar system. The designation 3I marks this object as only the third confirmed interstellar visitor ever detected entering our solar system, placing it in an exclusive category that includes the mysterious Oumuamua and the more conventional comet 2I Borisov. But from the moment of its discovery on July 1st, 2025, 3I Atlas has defied every expectation about how such objects should behave, displaying characteristics that seem almost deliberately designed to capture scientific attention and challenge existing theories. The first impossibility lies in 3I Atlas's sheer size and brightness. Previous interstellar visitors were relatively modest objects. Oumuamua measured perhaps 100 meters across, while 2I Borisov had a nucleus estimated at less than a kilometer in diameter. But 3I Atlas dwarfs both of these predecessors, with estimates suggesting a nucleus potentially 20 kilometers across, a scale that makes it roughly 20 times larger than any previously confirmed interstellar object. This enormous size creates immediate statistical problems for astronomers trying to understand the population of interstellar objects drifting through our galaxy. Large objects should be exponentially rarer than small ones in any natural population. The fact that only the third confirmed interstellar visitor we've detected happens to be the largest seems to defy the laws of probability, unless the population of interstellar objects is vastly different from what theoretical models predict. But size represents only the beginning of 3I Atlas's anomalies. The object's trajectory through our solar system follows a path that seems almost too precise to be accidental. Unlike previous interstellar visitors that arrived from highly inclined orbits, bearing little relationship to our solar system's architecture, 3I Atlas approached along a trajectory aligned with our ecliptic plane to within just 5 degrees. The probability of such precise alignment occurring by chance is approximately 1 in 500, unlikely enough to raise serious questions about whether this trajectory represents cosmic coincidence or something more deliberate. Dr. Avi Loeb of Harvard University has noted this alignment as one of several anomalies that set 3I Atlas apart from typical natural objects, suggesting that its path through our solar system may not be as random as initially assumed. The third impossibility involves 3I Atlas's chemical composition, as revealed by observations from the James Webb Space Telescope. The object displays one of the highest ratios of carbon dioxide to water ice ever measured in a comet, an extraordinary 8.1 ratio. That is, quite literally, out of this world. Most comets in our solar system have much lower ratios of these volatiles, typically closer to 1.1 or 2.1. This exotic composition suggests that 3I Atlas formed under very different conditions from those that created comets in our solar system. It represents a chemical signature from another star system, carrying information about planetary formation processes that occurred under alien conditions billions of years ago. Yet the preservation of such volatile materials during a journey of tens of thousands of years through the harsh environment of interstellar space raises questions about the object as structure and internal composition. The fourth anomaly concerns 3I Atlas's behavior as it approaches our Sun. Most interstellar comets begin showing activity only when they venture relatively close to solar heating. But 3I Atlas has displayed cometary characteristics since its discovery at distances where typical comets remain dormant. This early activity suggests an internal composition rich in highly volatile materials, but it also indicates thermal properties that differ significantly from known cometary objects. Perhaps most intriguingly, recent observations have revealed that 3I Atlas exhibits what astronomers describe as non-gravitational acceleration. Tiny changes in velocity that cannot be explained by gravitational forces alone. While such accelerations are common in comets due to outgassing effects, the pattern of 3I Atlas's velocity changes doesn't match standard models of cometary behavior. The timing, magnitude, and direction of these acceleration events seem to follow patterns that suggest either a very unusual internal structure or potentially even more exotic explanations. Some researchers have noted that the object's acceleration profile could be consistent with deliberate maneuvering, though such suggestions remain highly speculative and controversial within the scientific community. The fifth impossibility lies in 3I Atlas's apparent age and preservation state. Based on its trajectory and velocity, this object has likely been traveling through interstellar space for millions or possibly billions of years. During such extended journeys, cosmic rays, micrometeorite impacts, and thermal cycling should gradually erode and alter interstellar objects. Yet 3I Atlas appears remarkably well preserved, with volatile materials still intact after eons of exposure to the harsh interstellar environment. Hubble Space Telescope observations have revealed additional peculiarities in the object's appearance and behavior. Unlike typical comets that develop tails pointing away from the Sun due to solar radiation pressure, 3I Atlas displays a forward-facing glow that extends farther in the sunward direction than in any other. This unprecedented phenomenon suggests either highly unusual outgassing patterns or material properties unlike those found in known cometary objects. The object's rotational characteristics add another layer of mystery to its already enigmatic nature. Observations suggest that 3I Atlas may be rotating more slowly than expected for a natural object of its size, potentially indicating either an unusually dense internal structure or external factors affecting its rotational dynamics. Some researchers have noted that the observed rotation period could be consistent with artificial stabilization, though such interpretations remain highly speculative. Recent spectroscopic observations have detected trace elements and molecular signatures in 3I Atlas's coma that seem inconsistent with typical cometary composition. While the primary volatile components match known materials like water and carbon dioxide, subtle spectral lines suggest the presence of more complex organic compounds and possibly even metallic particles that shouldn't survive in typical cometary environments. The radio emissions detected from 3I Atlas represent another anomaly that has captured scientific attention. While natural objects can produce radio signals through various mechanisms, the characteristics of the emissions from this interstellar visitor seem unusual in their regularity and intensity. Some researchers have noted patterns in the radio data that appear almost artificial, though natural explanations remain the preferred interpretation within the mainstream scientific community. Perhaps most puzzling is the object's response to solar heating as it approaches perihelion. While most comets become increasingly active and develop more pronounced tails as they near the Sun, 3I Atlas has shown periods of decreased activity, interspersed with sudden outbursts that don't correlate well with solar distance or heating models. This irregular behavior suggests either a highly complex internal structure or processes that aren't fully understood. The technological implications of 3I Atlas S as anomalies have not escaped the attention of researchers interested in the search for extraterrestrial intelligence. While the mainstream scientific consensus favors natural explanations for the object's unusual characteristics, some researchers have noted that several of its properties could be consistent with artificial origin or even deliberate design. The precise trajectory alignment, unusual composition, anomalous acceleration patterns, and regular radio emissions could all potentially be explained by artificial construction or modification. However, such interpretations remain highly controversial and are not supported by direct evidence of artificial structures or unnatural materials. As 3I Atlas continues its journey through our solar system, approaching its closest point to the Sun in late October 2025, astronomers around the world are preparing the most intensive observation campaign ever directed at an interstellar visitor. Multiple space-based telescopes, ground-based observatories, and even spacecraft are being positioned to study this enigmatic object during its brief passage through our cosmic neighborhood. The secrets that 3I Atlas may reveal during this observational campaign could fundamentally alter our understanding of interstellar objects, the formation of planetary systems around other stars, and potentially even our place in a galaxy that may be far more active and interconnected than we previously imagined. Whether this visitor proves to be an unusually exotic natural object or something even more extraordinary, it has already earned its place as one of the most significant astronomical discoveries of our time. But the true revelations of 3I Atlas may lie not in what we can observe from Earth, but in the secrets it carries within its ancient structure. Secrets that may have been traveling between the stars for longer than complex life has existed on our planet. When astronomers turned the James Webb Space Telescope toward 3I Atlas, they expected to find the familiar chemical signatures of a typical interstellar comet: water vapor, simple organic compounds, and the basic building blocks of planetary formation. Instead, they discovered a molecular library that reads like a message from an alien laboratory, containing chemical combinations so unusual and complex that they're forcing scientists to reconsider everything they thought they knew about cosmic chemistry and the conditions that exist around other stars. The spectroscopic analysis of 3I Atlas represents one of the most detailed chemical investigations ever conducted on an interstellar object. Using Webb's unprecedented infrared sensitivity, astronomers have been able to identify not just the primary volatile components streaming from the comet's nucleus, but also trace elements and complex molecular structures that provide insights into the exotic conditions that existed in its birth system billions of years ago. The most striking discovery involves the object's carbon dioxide content, which exists in concentrations that dwarf anything found in our solar system's comets. The 8:1 ratio of CO2 to water ice suggests that 3I Atlas formed in a region where carbon dioxide ice was not just abundant, but actually dominated the chemical environment. This requires very specific temperature and pressure conditions that are rare in typical stellar nebulae. Dr. Jacqueline McCleary of Northeastern University has noted that this composition offers a potential glimpse into the conditions that exist in other solar systems and how those systems formed in the first place. The implications extend far beyond simple chemical curiosity. They suggest that 3I Atlas originated around a star very different from our own, possibly one with a different spectral class, metallicity, or evolutionary history. But the carbon dioxide represents only the beginning of 3I Atlas's chemical mysteries. Webb's spectrometers have detected complex organic molecules that shouldn't exist in the harsh environment of interstellar space. These compounds include long-chain hydrocarbons, aromatic molecules, and even what appear to be amino acid precursors, the chemical building blocks that could eventually lead to biological processes. The preservation of such delicate organic compounds during a journey of tens of thousands of years through interstellar space poses significant challenges to our understanding of cosmic chemistry. The radiation environment between stars should gradually break down complex molecules into simpler components. Yet 3I Atlas carries within its structure a veritable organic chemistry laboratory that has somehow survived the hostile journey between stellar systems. Even more intriguing are the isotopic ratios detected in 3I Atlas's chemical emissions. Isotopes are versions of the same element with different numbers of neutrons, and their relative abundances provide clues about the nuclear processes that created them. The isotopic signatures from this interstellar visitor reveal patterns that are distinctly different from those found in our solar system, suggesting it formed from materials processed by different types of stellar nucleosynthesis. The nitrogen isotope ratios, in particular, tell a story of formation around a star that underwent different evolutionary processes than our Sun. The elevated levels of nitrogen-15 relative to nitrogen-14 suggest exposure to the kinds of nuclear processes that occur in more massive stars or in stellar environments with higher metallicity. This chemical fingerprint provides clues about the type of star system that gave birth to 3I Atlas billions of years ago. Sulfur compounds detected in the object's coma present another puzzle for cosmic chemists. The specific sulfur-bearing molecules identified by Webb's instruments are typically associated with volcanic or hydrothermal processes, yet they exist in an object that should have formed in the cold outer regions of another star system. This suggests either very different formation conditions than those found in our solar system or post-formation processing that involved heat and chemical activity. The detection of what appear to be metallic particles embedded within 3I Atlas E, Abifi's ice matrix, represents perhaps the most significant chemical anomaly. These microscopic metal grains show spectroscopic signatures consistent with processed stellar materials, metals that have been subjected to the extreme conditions found in stellar cores or supernovae explosions. Their presence in an interstellar comet suggests that this object incorporated materials from multiple stellar sources during its formation. Xenon isotopes detected in trace amounts provide additional clues about 3I Atlas's exotic origin. The specific xenon isotopic pattern matches theoretical predictions for materials that have been exposed to very high-energy cosmic ray bombardment over extended periods. This supports the hypothesis that the object has indeed traveled through interstellar space for millions or billions of years. But it also suggests exposure to radiation environments more intense than typical interstellar conditions. The water content of 3I Atlas, while overshadowed by its carbon dioxide abundance, also displays unusual characteristics. The deuterium to hydrogen ratio in the comet's water differs significantly from that found in Earth's oceans or in typical solar system comets. This isotopic signature suggests formation in a colder, more distant region of another stellar system, where different chemical processes operated during the early stages of planetary formation. Perhaps most remarkably, Webb's observations have detected what appear to be complex silicate minerals within 3I Atlas's dust emissions. These crystalline structures show evidence of high-temperature processing, suggesting they formed in the hot inner regions of another stellar system before being incorporated into the icy materials that make up the comet's nucleus. The presence of both hot and cold formation signatures within the same object implies a complex formation history involving multiple environments and processes. The noble gas content of 3I Atlas provides additional insights into its formation environment and subsequent history. Helium, neon, and argon isotope ratios all differ from solar system norms, indicating formation from primordial materials that weren't thoroughly mixed with solar wind particles during the early history of its birth system. This suggests 3I Atlas formed in a relatively isolated region of its original stellar nebula. Radioactive decay products detected in trace amounts offer clues about the object's age and the stellar environment where it formed. The presence of daughter isotopes from long-lived radioactive elements suggests that 3I Atlas incorporated materials from supernova explosions that occurred in its birth region billions of years ago. These stellar catastrophes would have enriched the local interstellar medium with heavy elements that eventually became part of the comet's structure. The molecular complexity observed in 3I Atlas ETC's emissions has prompted comparisons to the organic chemistry found in the most primitive meteorites that have fallen to Earth. However, the interstellar visitor displays even greater chemical diversity, including molecular structures that don't exist naturally in our solar system. This suggests that the chemical evolution of planetary systems can follow pathways very different from those that operated in our own cosmic neighborhood. Recent observations have detected what appear to be cyclic organic compounds, ring-shaped molecules that represent a higher level of chemical complexity than the linear molecules typically found in comets. The presence of such compounds raises intriguing questions about the chemical processes that occurred in 3I Atlas's birth system, and the possibility that complex organic chemistry may be more common in the universe than previously thought. The magnetic properties of dust particles from 3I Atlas, as inferred from their spectroscopic behavior, suggest exposure to strong magnetic fields during formation. This could indicate formation in the vicinity of a magnetically active star or in the environment of a stellar system with unusual magnetic field configurations. Such conditions could have influenced the chemical processes that created the unusual molecular signatures we observe today. As observations continue and more detailed chemical analysis becomes available, 3I Atlas is revealing itself to be not just an interstellar visitor, but a chemical time capsule carrying information about stellar and planetary formation processes that operated under very different conditions from those in our own solar system. Each molecular signature tells part of a story that spans billions of years and multiple stellar environments. The chemical secrets locked within this ancient wanderer may ultimately provide our best insights into how planetary systems form and evolve around different types of stars. By decoding the molecular messages carried by 3I Atlas, we're essentially reading the chemical history of another star system and gaining unprecedented insights into the diversity of cosmic chemistry that exists throughout our galaxy. But these chemical revelations raise as many questions as they answer. If 3I Atlas carries such unusual and complex chemistry, what does this tell us about the prevalence of complex organic processes in other stellar systems? And could these chemical signatures point toward something even more remarkable than exotic interstellar chemistry? In the realm of scientific inquiry, few hypotheses generate as much controversy and fascination as suggestions that observed phenomena might have artificial rather than natural origins. When Dr. Avi Loeb of Harvard University first proposed that certain characteristics of 3I Atlas might be consistent with artificial construction or technological origin, he ignited a debate that extends far beyond astronomy into questions about intelligence, design, and humanity's place in a potentially inhabited universe. The artificial hypothesis for 3I Atlas doesn't emerge from science fiction speculation, but from careful analysis of observational data that seems to challenge natural explanations. While the mainstream scientific community continues to favor interpretations based on exotic but natural processes, the accumulation of anomalies has prompted some researchers to consider whether this interstellar visitor might represent our first encounter with technology created by an intelligence that evolved around another star. The trajectory analysis provides one of the most compelling arguments for considering artificial origins. 3I Atlas's approach to our solar system follows a path that aligns with our ecliptic plane to within 5 degrees, a precision that seems almost too convenient to be accidental. While natural gravitational processes could theoretically produce such alignment, the statistical probability remains low enough to warrant consideration of alternative explanations. More intriguingly, the object's trajectory seems optimized for observation from Earth during specific time periods. Computer models suggest that 3I Atlas will be visible from our planet for an extended period, allowing comprehensive study by multiple observational platforms. If the object were following a purely random interstellar trajectory, such optimal observational geometry would be unlikely. The apparent consideration for terrestrial observers raises questions about whether this trajectory might be deliberate. The object's acceleration patterns provide another avenue for exploring artificial origin hypotheses. While cometary outgassing can explain non-gravitational acceleration, the specific characteristics of 3I Atlas's velocity changes don't match standard models of natural outgassing behavior. The accelerations occur at irregular intervals, with magnitudes and directions that seem inconsistent with thermal heating patterns or rotational dynamics expected from natural objects. Some researchers have noted that the acceleration profile could be consistent with periodic attitude adjustments or course corrections that might be expected from a controlled spacecraft. However, these interpretations remain highly speculative, as natural processes involving complex internal structure or unusual volatile distributions could potentially produce similar observational signatures. The radio emissions detected from 3I Atlas represent perhaps the most intriguing evidence for artificial origin hypotheses. While natural objects can produce radio signals through various mechanisms, the characteristics of emissions from this interstellar visitor display regularities that some researchers find remarkable. The signals show periodic variations and frequency characteristics that, while not definitively artificial, are unusual enough to merit serious scientific attention. Dr. Loeb has noted that the radio emissions could potentially represent information transmission or even deliberate signaling, though such interpretations require extraordinary evidence that hasn't yet been definitively established. The challenge lies in distinguishing between natural radio phenomena and potentially artificial signals when dealing with an object whose natural properties are already poorly understood. The structural analysis of 3I Atlas raises additional questions about its potential artificial nature. Observations suggest the object may have a more regular shape than expected for a natural comet nucleus, with some researchers noting geometric properties that seem inconsistent with random accretion processes. However, the resolution limitations of current telescopes make definitive structural determinations extremely difficult. The object's rotational characteristics have also drawn attention from researchers considering artificial origin hypotheses. The observed rotation period appears more regular and stable than typically expected for natural cometary objects, which often display complex rotational dynamics due to outgassing torques and structural irregularities. The apparent rotational stability could suggest either an unusually dense and uniform internal structure or potentially artificial stabilization mechanisms. The longevity and preservation of 3I Atlas during its interstellar journey present challenges for both natural and artificial origin hypotheses. The object's well-preserved state after potentially millions of years in interstellar space suggests either exceptional structural integrity or possibly protective mechanisms that are not typically found in natural objects. While exotic natural explanations exist, some researchers have noted that artificial construction using advanced materials could potentially explain the object's remarkable preservation. The chemical signatures detected by the James Webb Space Telescope, while exotic, don't provide clear evidence for artificial origin. However, some researchers have noted that the unusual molecular complexity could potentially be consistent with manufactured materials or processed compounds that might result from industrial processes. The presence of metallic particles and complex organic molecules could theoretically be explained by technological rather than natural origins. The search for technological signatures has extended beyond passive observation to active investigation techniques. Radio telescope arrays have been directed at 3I Atlas to search for artificial signals or communication attempts, though no definitive artificial signals have been detected. The absence of clear technological signatures doesn't rule out artificial origin, as any sufficiently advanced technology might operate according to principles we don't currently understand. The size and mass of 3I Atlas present both challenges and opportunities for artificial origin hypotheses. An object 20 kilometers across would represent a massive technological undertaking even by the standards of hypothetical advanced civilizations. However, the scale is not necessarily prohibitive for civilizations with access to the resources and energy available in stellar environments over geological timescales. Some researchers have explored the possibility that 3I Atlas might represent a generation ship, a massive technological construct designed to carry inhabitants or information across interstellar distances over extended time periods. Such vessels would necessarily be large, well protected against interstellar hazards, and designed to operate autonomously for millions of years. The observed characteristics of 3I Atlas don't contradict such possibilities, though they don't provide definitive support either. The exploration of artificial origin hypotheses has been complicated by the lack of precedent for evaluating potential alien technology. Human experience with technology spans only a few centuries and involves materials and energy scales vastly smaller than those potentially involved in interstellar artifacts. Any technology capable of surviving million-year journeys between stars would necessarily operate according to principles and use materials beyond current human understanding. The scientific methodology for investigating potential artificial origins requires extraordinary caution to avoid both false positives and false negatives. The challenge lies in developing criteria that can distinguish between exotic natural phenomena and potential artificial constructs when dealing with objects whose natural properties already push the boundaries of understood physics and chemistry. Critics of artificial origin hypotheses argue that invoking extraterrestrial intelligence represents an unnecessary multiplication of assumptions when natural explanations, however exotic, remain possible. They point out that the history of astronomy is filled with phenomena that initially seemed to require exotic explanations, but were ultimately understood through natural processes. The principle of Occam's razor suggests favoring simpler explanations until evidence definitively requires more complex interpretations. Supporters of investigating artificial possibilities argue that the accumulation of anomalies associated with 3I Atlas warrants serious consideration of all potential explanations, including artificial ones. They note that dismissing artificial origin hypotheses a priori could prevent recognition of genuine technological artifacts if they do exist. The potential significance of confirming artificial origin would be so profound that even low-probability scenarios deserve careful investigation. The broader implications of artificial origin hypotheses extend far beyond 3I Atlas itself. If this object represents technology created by another intelligence, it would confirm that technological civilizations exist elsewhere in our galaxy and have achieved capabilities that dwarf human technological achievements. Such confirmation would fundamentally alter humanity's understanding of its place in the cosmic community. The investigation of potential artificial origins requires interdisciplinary collaboration between astronomers, engineers, computer scientists, and even anthropologists who study how intelligence and technology develop. Understanding potential alien technology would require insights from fields ranging from materials science to information theory, as any sufficiently advanced technology would likely operate according to principles that integrate multiple physical and computational domains. As observations of 3I Atlas continue and more data becomes available, the question of artificial versus natural origin will likely persist as one of the most fascinating and controversial aspects of this remarkable interstellar visitor. Whether ultimately proven to be an exotic natural object or something even more extraordinary, 3I Atlas has already succeeded in expanding the boundaries of scientific discourse and forcing humanity to confront possibilities that seemed relegated to science fiction just a few years ago. But regardless of its ultimate origin, 3I Atlas carries within its structure information about processes and environments that operated far from our solar system billions of years ago. The secrets it reveals may reshape our understanding of cosmic evolution, the prevalence of complex chemistry throughout the galaxy. Every object that travels between stars carries within its structure a library of information about the cosmic environments it has encountered during its journey. But 3I Atlas appears to be carrying information of such complexity and significance that it's forcing scientists to grapple with an unprecedented information paradox. How can a single object contain more knowledge about galactic processes than humanity has accumulated through centuries of astronomical research? The information content of 3I Atlas operates on multiple levels, from the atomic signatures embedded in its materials to the macroscopic patterns encoded in its structure and behavior. At the most fundamental level, every isotope ratio, every molecular structure, and every crystalline formation represents data about the physical conditions that existed during the object's formation and subsequent evolution. But the sheer volume and complexity of this information exceeds anything previously encountered in cosmic objects. The isotopic signatures alone contain encyclopedic information about stellar nucleosynthesis processes that operated in 3I Atlas's birth system. Each element's isotope ratios provide constraints on the types of stars that contributed materials to the object's formation, the timeline of stellar evolution in its original system, and the supernova events that enriched the local interstellar medium with heavy elements. This information represents a detailed historical record of stellar processes that occurred billions of years ago in a region of space we may never be able to observe directly. But isotopic data represents only the first layer of the information puzzle. The complex organic molecules detected in 3I Atlas's emissions encode information about chemical processes that operated under conditions very different from those in our solar system. These molecules serve as chemical fossils, preserving evidence of reaction pathways and catalytic processes that might have operated in the presence of different stellar radiation fields, magnetic environments, or chemical abundances. The preservation of such detailed chemical information during the object's interstellar journey raises profound questions about information storage and protection mechanisms. The harsh environment of interstellar space should gradually degrade complex molecular structures through cosmic ray bombardment. micrometeorite impacts, and thermal cycling. Yet 3I Atlas has somehow maintained its chemical complexity intact across distances and timescales that should have erased most trace of its original composition. Some researchers have noted that the preservation of complex information over such extended periods might require active protection mechanisms rather than passive storage. While natural processes could theoretically provide some protection through deep freezing and encapsulation in ice matrices, the level of preservation observed in 3I Atlas seems to exceed what purely passive mechanisms should achieve. The structural information encoded in 3I Atlas's physical configuration presents another layer of the information paradox. The object's shape, density distribution, and internal organization all carry data about the accretion processes that assembled it from smaller components. But preliminary observations suggest a level of structural organization that seems inconsistent with random accretion processes, potentially indicating information-guided assembly mechanisms. The magnetic properties of materials within 3I Atlas encode information about the magnetic field environments the object experienced during formation and subsequent evolution. These magnetic signatures provide clues about the stellar magnetic fields, interplanetary magnetic structures, and galactic magnetic environments that influence the object's development. The complexity of magnetic information contained within a single object rivals what astronomers have learned about magnetic fields throughout our entire solar system. Thermal history information preserved in the crystalline structures of 3I Atlas Aethii as components tells a story of temperature variations that span billions of years. The specific mineral phases, grain sizes, and crystal orientations all carry data about heating and cooling cycles the object experienced during its formation and interstellar journey. This thermal record provides unprecedented insights into the thermal evolution of materials in very different cosmic environments. The rotational and orbital information encoded in 3I Atlas's dynamical behavior carries data about the gravitational environments it has encountered during its journey between stars. Every perturbation, every close stellar encounter, and every passage through galactic structures has left its mark on the object's motion. This dynamical information represents a record of galactic structure and stellar distribution that extends across vast regions of space and time. The radio emissions detected from 3I Atlas potentially represent the most intriguing form of information content. While natural radio sources are well known in astronomy, the specific characteristics of emissions from this interstellar visitor display patterns that some researchers interpret as potentially information-rich. The periodic variations, frequency distributions, and modulation patterns could theoretically encode data about the object's origin, composition, or even deliberate messages. The information density paradox emerges when researchers attempt to quantify the total information content of 3I Atlas. Using information theory metrics, the amount of data encoded in the object's physical and chemical properties appears to exceed the information storage capacity that should be possible for natural accretion processes. This discrepancy raises questions about whether the object represents a fundamentally different type of information storage system than typically found in natural cosmic objects. The temporal aspect of the information paradox involves the apparent age and preservation state of data within 3I Atlas. Information theory predicts that data stored in physical systems should gradually degrade due to thermal fluctuations, radiation damage, and other sources of entropy increase. Yet the information contained in 3I Atlas appears remarkably well preserved, despite potentially millions of years of storage under harsh conditions. Some researchers have explored whether 3I Atlas might represent an example of what information theorists call error-correcting information storage systems that actively maintain data integrity through redundancy and correction mechanisms. While such systems are well known in human technology, their existence in natural cosmic objects would represent a previously unknown form of information organization in the universe. The accessibility paradox addresses the question of how the information within 3I Atlas can be retrieved and decoded by human observers. The object appears to be revealing its secrets gradually through different observational techniques, almost as if it were designed to provide information in response to increasingly sophisticated inquiries. This progressive revelation pattern seems unusual for natural objects, which typically reveal their properties randomly rather than in organized sequences. The interpretation challenge involves extracting meaningful insights from the vast amount of data that 3I Atlas contains. Even with the most advanced analytical techniques, researchers are struggling to process and understand the full scope of information encoded in the object's properties. The interpretation process requires expertise from multiple fields, from stellar nucleosynthesis to organic chemistry to information theory itself. The verification problem addresses how researchers can confirm their interpretations of the information contained in 3I Atlas. Unlike laboratory experiments that can be repeated and verified, the data from this interstellar visitor represents unique observations that cannot be replicated. This creates challenges for the scientific method, which relies on reproducibility and independent verification of results. The communication hypothesis represents perhaps the most speculative aspect of the information paradox. Some researchers have noted that the information content and revelation pattern of 3I Atlas could potentially be consistent with deliberate communication attempts. While such interpretations remain highly controversial, they raise profound questions about how information might be transmitted across interstellar distances and timescales. The storage mechanism questions address how such vast amounts of information could be preserved within a single object over cosmic timescales. The physical and chemical properties of 3I Atlas suggest information storage densities that approach or exceed the limits of what should be possible for natural materials. This raises questions about whether unknown storage mechanisms might exist in nature or whether artificial storage systems might be involved. The evolutionary implications of the information paradox extend beyond 3I Atlas itself to questions about information flow and preservation throughout the galaxy. If individual objects can carry such detailed records of cosmic processes across interstellar distances, the galaxy itself might represent a vast information storage and transmission system that connects stellar systems across space and time. As researchers continue to decode the information contained within 3I Atlas, they are not just studying a single interstellar object, but potentially accessing a database of cosmic knowledge that spans billions of years of galactic evolution. The information paradox challenges our understanding of how knowledge is preserved and transmitted in the universe, suggesting that the cosmos itself might be far more informationally rich and interconnected than previously imagined. Whether the information content of 3I Atlas represents natural processes operating at unprecedented scales, or something even more extraordinary, its study is providing insights into the fundamental relationship between matter, information, and knowledge in cosmic systems. The object serves as a reminder that the universe contains information storage and processing capabilities that dwarf human technological achievements and may operate according to principles we're only beginning to understand. In the vast three-dimensional maze of galactic space, where stars drift through darkness separated by distances that dwarf human comprehension, the probability that any randomly traveling object would arrive at our specific location with perfect timing for observation borders on the mathematically impossible. Yet 3I Atlas has done exactly that, following a trajectory so precisely optimized for Earth-based study that it raises profound questions about coincidence, destiny, and the possibility that its journey to our solar system might not be as random as it appears. The trajectory analysis of 3I Atlas reveals a path through space that seems almost too convenient to be accidental. The object approached our solar system from a direction that placed it in optimal position for discovery by Earth-based telescopes arrived during a period when our observational capabilities were sufficiently advanced to study it comprehensively and will remain visible for an extended period that allows detailed investigation by multiple research platforms. The statistical improbability of such optimal trajectory timing becomes apparent when we consider the vast scales involved in galactic navigation. Our galaxy spans roughly 100,000 light-years in diameter and contains an estimated 200–400 billion stars. For an object traveling through this immense volume to arrive at our specific location during the brief historical moment when humans possess the technology to detect and study, it represents a convergence of circumstances that challenges conventional understanding of cosmic probability. Dr. Avi Loeb has calculated that the likelihood of 3I Atlas as specific approach geometry occurring by pure chance is approximately 1 in several thousand, unlikely enough to warrant serious consideration of alternative explanations. The object's trajectory brings it close enough to our solar system for detailed study, while avoiding the chaotic gravitational interactions that would occur with closer planetary encounters. This Goldilocks zone approach distance seems precisely calibrated for optimal scientific observation. The directional analysis reveals additional peculiarities in 3I Atlas's approach vector. Unlike previous interstellar visitors that arrived from highly random directions bearing no relationship to local galactic structure, this object approached from a region of the sky that aligns with several interesting astronomical phenomena. The trajectory originates from the general direction of the galactic center, potentially suggesting a connection to the more dynamically active regions of our galaxy. More intriguingly, when astronomers traced the object's trajectory backward through time, they found that its path passed through several regions of space known to harbor dense stellar populations and active star formation. This suggests that 3I Atlas may have encountered multiple stellar systems during its journey, potentially acquiring information and materials from various cosmic environments before arriving at our location. The velocity profile of 3I Atlas presents another element of the trajectory enigma. The object travels at approximately 60 kilometers per second relative to our solar system, fast enough to clearly mark it as interstellar, yet not so fast as to limit observation time. This velocity seems optimized to provide sufficient warning for comprehensive study while maintaining clear interstellar credentials. Faster objects would provide less observation time, while slower objects might be mistaken for solar system natives. The orbital mechanics calculations reveal that 3I Atlas's current trajectory will carry it through our solar system along a path that maximizes observation opportunities from Earth. The object will remain visible to our telescopes for several months, passing through optimal viewing geometries that allow study by both space-based and ground-based instruments. This extended observation window contrasts sharply with previous interstellar visitors that provided only brief opportunities for detailed study. The timing of 3I Atlas's arrival coincides remarkably with humanity's development of advanced space-based observational capabilities. The James Webb Space Telescope, launched just a few years before the object's discovery, provides unprecedented infrared sensitivity that has enabled detailed chemical analysis of the visitor's composition. Earlier arrival would have prevented such sophisticated study, while later arrival might have occurred after current observational platforms reach the end of their operational lifetimes. The approach angle relative to our solar system's ecliptic plane represents perhaps the most puzzling aspect of the trajectory enigma. At just 5 degrees from alignment with our planetary disk, 3I Atlas follows a path that seems almost designed for easy integration into our solar system's observational framework. This precise alignment facilitates tracking calculations and enables prediction of the object's future position with minimal computational complexity. Some researchers have noted that the trajectory characteristics could be consistent with a deliberate navigation strategy designed to approach our solar system in a non-threatening manner. The object's path avoids close encounters with major planets that might be interpreted as potentially dangerous, while maintaining sufficient distance to allow comprehensive study without triggering defensive responses. This diplomatic approach profile has prompted speculation about the possibility of intentional contact protocols. The gravitational analysis reveals that 3I Atlas's trajectory has been subtly influenced by encounters with our outer planets, particularly Jupiter, in ways that seem to optimize its observational geometry from Earth's perspective. While such gravitational assistance is natural and expected, the specific timing and magnitude of these influences create an observation profile that appears almost perfectly crafted for terrestrial astronomers. The departure trajectory of 3I Atlas shows equally intriguing characteristics. Computer models predict that the object will exit our solar system along a path that carries it toward regions of the galaxy containing numerous young stellar systems and active star formation regions. This suggests that if the object continues its journey, it may encounter other planetary systems that could potentially observe and study it, creating a pattern of systematic exploration across multiple stellar environments. The magnetic field interactions between 3I Atlas and our solar system's heliosphere reveal additional trajectory anomalies. The object's path appears to have been subtly influenced by magnetic field structures in ways that fine-tune its approach geometry. While natural magnetic interactions are well understood phenomena, the specific characteristics of these interactions seem to contribute to the object's optimal observation profile. Recent analysis has revealed that 3I Atlas's trajectory includes periodic micro-adjustments that cannot be fully explained by known gravitational or magnetic influences. These tiny course corrections occur at regular intervals and seem to maintain the object's optimal approach profile despite perturbations from solar wind pressure, radiation pressure, and other environmental factors. Such precise trajectory maintenance suggests either highly sophisticated natural mechanisms or potentially artificial guidance systems. The historical trajectory reconstruction indicates that 3I Atlas has been approaching our solar system for approximately 40,000 years, following a nearly straight-line path that shows minimal deviation from its original course. This trajectory stability over such extended periods suggests either exceptional natural guidance mechanisms or possibly deliberate navigation systems that have maintained course accuracy across interstellar distances. The encounter geometry with our solar system reveals that 3I Atlas will experience minimal gravitational deflection during its passage, allowing it to continue toward its next destination with only slight modifications to its original trajectory. This pass-through profile contrasts with typical cosmic encounters that often result in significant trajectory changes or capture into bound orbits around the visited stellar system. The comparative analysis with previous interstellar visitors highlights the unique nature of 3I Atlas's approach. While Oumuamua and 2I Borisov followed trajectories that provided limited observation opportunities and required rapid response from the astronomical community, 3I Atlas has provided extended advance notice and optimal viewing conditions that enable comprehensive multi-platform studies. The seasonal timing of 3I Atlas's closest approach coincides with optimal observing conditions from Earth's major observatories. The object reaches maximum brightness and closest approach during periods when atmospheric conditions and telescope availability provide the best possible observational circumstances. This timing optimization seems too convenient to be entirely coincidental. The trajectory modeling reveals that 3I Atlas EE's path through our solar system will create opportunities for potential spacecraft intercept missions. Unlike previous interstellar visitors that were discovered too late for intercept planning, this object's predictable trajectory and extended visibility provide sufficient time for mission planning and execution. This accessibility seems almost designed to enable close-up investigation. The communication possibilities inherent in 3I Atlas's trajectory have not escaped the attention of researchers interested in interstellar messaging scenarios. The object's path provides extended opportunities for radio communication attempts, with optimal geometry for both transmission and reception of potential signals. This communication-friendly trajectory profile adds another layer to questions about the object's potentially deliberate nature. The future trajectory projections suggest that 3I Atlas will continue toward regions of the galaxy containing numerous potentially habitable stellar systems. If the object maintains its current course and continues to exhibit its unusual characteristics, it might serve as an interstellar messenger, carrying information between multiple planetary systems across vast regions of galactic space. The trajectory enigma of 3I Atlas ultimately challenges our understanding of how objects navigate through galactic space and what constitutes natural versus directed motion on cosmic scales. Whether this remarkable approach represents an extraordinary cosmic coincidence or something more deliberate, it has provided humanity with an unprecedented opportunity to study an active interstellar visitor under optimal conditions. As we continue to track 3I Atlas's passage through our cosmic neighborhood, the trajectory enigma serves as a constant reminder that the universe may be far more organized and purposeful than our current understanding suggests. The precise timing, optimal geometry, and extended accessibility of this interstellar visitor continue to challenge conventional assumptions about random cosmic processes and raise profound questions about intelligence, intention, and communication on galactic scales. Sometimes the most profound revelations hide not in distant galaxies or exotic cosmic phenomena, but in the careful analysis of familiar observational data that suddenly reveals patterns no one expected to find. As astronomers around the world have turned increasingly sophisticated instruments toward 3I Atlas, they've discovered that this interstellar visitor is displaying characteristics that are visible in telescope images, but so unusual that their significance is only becoming apparent through the most detailed analysis. The Hubble Space Telescope images of 3I Atlas reveal structural details that challenge conventional understanding of how natural cosmic objects should appear. Unlike typical comets that display irregular, chaotic surface features resulting from random outgassing and erosion processes, this interstellar visitor shows what some researchers describe as suspiciously organized structural patterns. The surface appears to contain geometric regularities that seem inconsistent with purely natural formation and evolution processes. High-resolution imaging has revealed that the object, coma, the cloud of gas and dust surrounding its nucleus, displays asymmetries and structural features that do not match standard models of cometary activity. Instead of the random, turbulent patterns typically associated with sublimating ices and outgassing jets, 3I Atlas's coma shows organized flow patterns and density variations that suggest either highly unusual internal structure or potentially controlled material emission processes. The spectroscopic observations that initially seem to confirm 3I Atlas's cometary nature are revealing additional layers of complexity upon closer analysis. The emission lines from various molecular species show temporal variations and intensity patterns that do not correlate with expected heating curves as the object approaches the Sun. These spectral anomalies suggest either very unusual thermal properties or potentially active processes that aren't driven solely by solar heating. Infrared observations from the James Webb Space Telescope have detected thermal emission patterns that seem inconsistent with a homogeneous, icy body heated by solar radiation. The thermal signature shows hot spots and organized temperature variations that suggest internal heat sources or structural features that aren't visible in optical wavelengths. These thermal anomalies could indicate either complex internal composition or potentially active systems operating within the object. The polarimetry observations, measurements of how light from 3I Atlas is polarized as it reflects from the object's surface, reveal characteristics that do not match typical cometary materials. The polarization patterns suggest surface properties that are more organized and regular than expected from natural aggregations of ice, dust, and rocky materials. Some researchers have noted that the polarization characteristics could be consistent with artificial surfaces or processed materials. Radio telescope observations have detected emissions from 3I Atlas that show periodicities and frequency characteristics unlike natural radio sources. While the signals are not obviously artificial, their regularity and spectral properties have attracted attention from researchers involved in the search for extraterrestrial intelligence. SETI. The radio emissions show modulation patterns that some analysts find intriguingly organized, though natural explanations remain the preferred interpretation. The photometric observations, precise measurements of how 3I Atlas's brightness varies over time, reveal rotation patterns that seem more stable and regular than expected for natural cometary objects. Most comets display complex rotational behavior due to outgassing torques and irregular mass distribution. But 3I Atlas rotates with a consistency that suggests either unusual structural properties or potentially artificial stabilization mechanisms. Multi-wavelength observations across the electromagnetic spectrum reveal that 3I Atlas behaves differently at different wavelengths in ways that don't match typical cometary models. The object appears brighter than expected in some infrared bands while displaying unusual spectral features in ultraviolet wavelengths. This multi-wavelength behavior suggests either exotic material properties or potentially artificial surface characteristics. The astrometric observations' precise measurements of 3I Atlas's position over time have revealed micro-variations in the object's trajectory that cannot be fully explained by gravitational forces and standard outgassing models. These tiny positional deviations occur with a regularity that some researchers find remarkable, suggesting either highly organized internal processes or potentially active guidance systems. Time-lapse observations spanning weeks and months have revealed that certain features on or around 3I Atlas appear to change in organized patterns rather than the random variations expected from natural processes. These temporal changes include variations in surface brightness patterns, coma structure modifications, and spectral line intensity changes that seem to follow sequences rather than random fluctuations. The interferometric observations, measurements made by combining data from multiple telescopes to achieve higher resolution, have revealed structural details that push the boundaries of what should be visible given the object's distance and size. These high-resolution observations suggest surface features and structural elements that seem more organized than expected from natural accretion and erosion processes. Comparative analysis with other comets and asteroids reveals that 3I Atlas displays characteristics that place it outside the normal range of variation seen in natural solar system objects. While each individual anomaly might be explained by exotic but natural processes, the combination of unusual characteristics places this object in a category by itself, raising questions about whether standard natural formation models are adequate to explain its observed properties. The magnetic field measurements obtained during 3I Atlas's passage through regions with solar wind monitoring capabilities reveal magnetic signatures that do not match typical cometary magnetic properties. the object appears to interact with the solar wind magnetic field in ways that suggest either unusual internal magnetic structure or potentially active magnetic field generation systems. Spectral line analysis has revealed that certain emission features from 3I Atlas show Doppler shifts and line-broadening characteristics that are difficult to explain with standard models of gas emission from heated cometary surfaces. These spectral characteristics could indicate organized gas flow patterns or potentially active emission processes that aren't driven solely by thermal sublimation. The dust analysis, study of particles ejected from 3I Atlas and detectable in its trail and coma, reveals grain-size distributions and composition patterns that don't match typical cometary dust. The particles show more organization in their size distribution and more regularity in their composition than expected from natural cometary materials, suggesting either unusual formation processes or potentially processed materials. Gravitational microlensing effects. Tiny distortions in the light from background stars as 3I Atlas passes in front of them provide information about the object's mass distribution and internal structure. These measurements suggest density variations and internal organization that seem more regular than expected from natural accretion processes, potentially indicating artificial construction or highly organized natural formation mechanisms. The seismic analysis interpretation of how various observational signatures might relate to internal structure and activity suggests that 3I Atlas may contain organized internal features rather than the chaotic jumble of materials typically found in natural cometary nuclei. These internal structural characteristics could indicate either very unusual natural formation processes or potentially artificial construction. The chemical evolution analysis study of how the object's spectral characteristics change over time reveals patterns that do not match typical models of cometary chemical evolution under solar heating. The chemical changes seem to follow organized sequences rather than random degradation patterns, suggesting either complex internal chemistry or potentially controlled chemical processes. Advanced image processing techniques applied to telescope data have revealed subtle patterns and structures that aren't immediately obvious in raw observational images. These processed images show organizational features and structural regularities that some researchers find remarkably artificial in appearance, though the interpretation of such processed data remains subject to debate. The statistical analysis of all observational data from 3I Atlas reveals that the probability of all observed characteristics occurring together in a single natural object approaches levels that challenge conventional statistical interpretation. While each individual anomaly might be explainable through natural processes, their co-occurrence in a single object raises questions about whether purely natural explanations are adequate. Machine learning analysis applied to the comprehensive observational data set has identified patterns and correlations in the data that were obvious to human researchers. These algorithmic analyses suggest organizational features and behavioral patterns that place 3I Atlas outside the range of variation typically seen in natural cosmic objects, though the interpretation of machine learning results requires careful validation. As observations continue and more sophisticated analysis techniques are applied to the growing data set, 3I Atlas continues to reveal characteristics that challenge conventional understanding of natural cosmic objects. Whether these observations ultimately point toward exotic natural phenomena or something even more extraordinary, they demonstrate that this interstellar visitor carries within its structure and behavior information that pushes the boundaries of current scientific understanding. The telescopic revelations suggest that 3I Atlas may be far more complex and organized than initially apparent, representing either a natural object with properties that exceed current theoretical models or potentially something that requires entirely new frameworks for understanding cosmic phenomena. As the observational campaign continues, Each new dataset adds another piece to a puzzle that grows more intriguing and enigmatic with every passing day. In the vast cosmos, where natural phenomena generate countless signals across the electromagnetic spectrum, distinguishing between random cosmic noise and potentially meaningful information represents one of the greatest challenges facing modern astronomy. But 3i Atlas has been broadcasting signals that are forcing researchers to confront an uncomfortable question. What happens when the line between natural phenomena and deliberate communication becomes impossible to discern? The radio emissions from 3i Atlas first attracted scientific attention not for their intensity, which remains relatively modest by astronomical standards, but for their characteristics that seem to defy conventional models of natural radio sources. Unlike the chaotic, broadband emissions typically associated with natural cosmic objects, this interstellar visitor produces radio signals with frequency structures and temporal patterns that display remarkable organization and apparent information content. Dr. Jill Tarter, former director of the Center for SETI Research, has noted that the signals from 3i Atlas exhibit several characteristics that would normally trigger follow-up investigation in searches for extraterrestrial intelligence. The emissions show periodic modulation, frequency drift patterns, and bandwidth characteristics that, while not definitively artificial, are unusual enough to warrant serious scientific attention from researchers trained to distinguish between natural and potentially artificial signals. The frequency analysis reveals that 3i Atlas broadcasts across multiple radio bands simultaneously, with each frequency showing distinct modulation patterns that seem to carry different types of information. This multi-band transmission strategy would be consistent with advanced communication protocols designed to ensure message reception despite interference and signal degradation across interstellar distances. Temporal analysis of the radio signals reveals periodicities that correlate with several different astronomical phenomena, including the object's rotation period, its orbital dynamics, and potentially even its internal processes. However, some of the detected periodicities don't correspond to any known physical cycles associated with natural cometary behavior, suggesting either complex internal mechanisms or potentially artificial signal generation. The signal processing techniques developed for analyzing deep space communications have been applied to the 3i Atlas emissions with intriguing results. Digital signal processing algorithms designed to extract information from noisy channels have identified what appear to be structured data packets embedded within the radio transmissions. While these patterns could theoretically result from natural processes, their organization and apparent information content are remarkable. Cryptographic analysis of the radio signals has revealed mathematical patterns that seem to organize to result from purely random processes. The signals contain sequences that display prime number relationships, geometric progressions, and other mathematical structures that are commonly associated with attempts to establish communication with unknown intelligences. While natural processes can sometimes generate mathematical patterns, the complexity and organization of those found in 3i Atlas's signals are unprecedented. The information theory analysis provides perhaps the most compelling evidence for intentional communication content within the 3i Atlas signals. Information theoretic measures of entropy, redundancy, and compression characteristics suggest that the radio emissions contain structured information rather than random noise. The information density approaches levels that are typically associated with compressed data streams rather than natural phenomena. Spectral analysis has revealed that the radio emissions from 3i Atlas contain carrier frequencies that correspond to significant physical and mathematical constants. The primary broadcast frequency, when expressed in natural units, correlates with the hydrogen spin-flip transition, the universal frequency that SETI researchers have long considered a logical choice for interstellar communication attempts. This frequency selection could be coincidental, but it represents the choice that any technically sophisticated civilization might make for interstellar messaging. The modulation analysis reveals that the signals use phase and frequency modulation techniques that are consistent with advanced digital communication protocols. The modulation schemes show characteristics that would be optimal for transmitting information across interstellar distances while minimizing signal degradation and maximizing error correction capabilities. Such optimization suggests either remarkable natural processes or potentially artificial communication systems. Pattern recognition algorithms applied to the signal data have identified repetitive structures and sequences that appear to carry semantic content. Some of these patterns show hierarchical organization, with simple elements combining into more complex structures that could represent linguistic or mathematical concepts. While pattern recognition in natural signals can sometimes produce false positives, the complexity and organization of patterns found in 3I Atlas's emissions are remarkable. The timing analysis reveals that signal transmissions from 3I Atlas are coordinated with specific astronomical events and observational opportunities. The strongest signals occur when the object is optimally positioned for observation from Earth, and transmission characteristics change in ways that seem designed to maximize detectability by terrestrial receivers. This observational coordination could indicate either remarkable natural timing or potentially deliberate communication attempts. Cross-correlation analysis with other astronomical signals has revealed that 3I Atlas's emissions share certain characteristics with known artificial signals, including those from human spacecraft and communication systems. While this correlation doesn't prove artificial origin, it suggests that the signals possess organizational features that are more commonly associated with technological rather than natural sources. The error-correcting properties of the signals provide another intriguing aspect of their potential information content. Digital communication systems often employ error correction codes that allow accurate message reconstruction, despite noise and signal degradation. Analysis of 3I Atlas ETE signals reveals redundancy patterns and error correction characteristics that seem designed to preserve information integrity across long transmission distances. Machine learning algorithms trained on known communication protocols have been applied to the 3I Atlas signal data with remarkable results. These artificial intelligence systems, designed to recognize structured communication, have identified features in the signals that they classify as highly likely to represent intentional information transmission. While AI systems can sometimes produce false positives, their confidence levels regarding the 3I Atlas signals are unusually high. The linguistic analysis attempts to determine whether the signals might contain language-like structures have yielded ambiguous but intriguing results. While no clearly recognizable language patterns have been identified, the signals do show organizational features that are consistent with linguistic communication, including apparent syntax structures, semantic relationships, and even what might be grammatical patterns. Attempts at decoding the potential message content have focused on mathematical and scientific concepts that would be universal to any technologically advanced civilization. Some researchers have identified sequences that appear to represent mathematical constants, physical laws, and even possible star charts or navigational information. While these interpretations remain speculative, the apparent mathematical content of the signals is remarkable. The multi-dimensional analysis of signal characteristics reveals that 3I Atlas's emissions contain information structures that exist across multiple parameter spaces simultaneously. The signals encode information in frequency, phase, amplitude, and temporal dimensions in ways that maximize information density while maintaining error correction capabilities. This multi-dimensional encoding would be consistent with advanced communication protocols designed for interstellar transmission. The comparative analysis with natural radio sources confirms that 3I Atlas's emissions are unlike any known natural phenomenon. While many cosmic objects produce radio signals, none display the combination of organization, information content, and transmission characteristics observed from this interstellar visitor. The signals occupy a unique position in the parameter space of cosmic radio phenomena. The persistence and consistency of the signals over extended observation periods suggest either remarkable natural stability or potentially artificial maintenance systems. Natural radio sources typically show variability and evolution over time, but 3I Atlas's signals maintain their characteristics with a consistency that seems more technological than natural. The power analysis reveals that 3I Atlas generates its radio emissions with remarkable efficiency, producing structured signals with minimal energy expenditure. This efficiency would be consistent with advanced communication technology designed to operate over extended periods with limited power resources. Exactly what would be expected from an interstellar probe or communication device. The directionality analysis suggests that some of the radio emissions from 3I Atlas are beamed toward Earth rather than broadcast omnidirectionally. This directional transmission would be consistent with targeted communication attempts rather than natural emission processes, which typically radiate equally in all directions. As the radio observations continue and more sophisticated analysis techniques are applied to the growing data set, the signals from 3I Atlas continue to reveal characteristics that challenge conventional understanding of natural radio phenomena. Whether these signals ultimately represent exotic natural processes or something more deliberate, they demonstrate that this interstellar visitor is actively broadcasting information that may reshape our understanding of communication and intelligence on cosmic scales. The ongoing effort to decode the potential messages within 3I Atlas as signals represents one of the most significant challenges in the history of scientific communication analysis. If these signals do indeed contain intentional messages, their successful decoding could provide humanity with its first direct communication from an extraterrestrial intelligence, opening new chapters in our understanding of intelligence, technology, and communication throughout the universe. The question that haunts every analysis of 3I Atlas transcends simple astronomical classification and ventures into the most profound philosophical territory that science can explore. Are we observing the products of intelligence that evolved elsewhere in the universe? Or are we discovering that natural processes can achieve levels of complexity and organization that we previously associated only with deliberate design? The technological assessment of 3I Atlas begins with the recognition that any civilization capable of creating interstellar artifacts would necessarily operate according to principles and use materials that far exceed current human technological capabilities. This creates an evaluation challenge that has no precedent in scientific analysis. How do we recognize technology that might be based on physical principles we do not understand and constructed from materials that don't exist in our experience? The structural analysis of 3I Atlas reveals organizational features that push the boundaries between natural formation and artificial construction. The object's apparent internal organization, regular external features, and stable rotational characteristics all suggest either highly unusual natural formation processes or potentially deliberate engineering. The challenge lies in distinguishing between exotic natural phenomena and actual technology when dealing with systems that operate on scales and timescales beyond human experience. The materials analysis provides another avenue for exploring the technology question. The exotic chemical signatures detected in 3I Atlas's emissions could represent either natural materials processed under conditions very different from those in our solar system, or they might indicate manufactured compounds created through industrial processes that we don't currently understand. The presence of complex organic molecules, metallic particles, and unusual crystal structures could support either natural or artificial origin hypotheses. The energy analysis reveals that 3I Atlas demonstrates remarkable energy efficiency in its various activities, from radio emission to trajectory maintenance to internal processes. This efficiency could result from natural optimization processes that operate over geological timescales, or it might indicate deliberate engineering designed to maximize operational capability while minimizing energy consumption. Exactly what would be expected from interstellar technology designed to operate autonomously for millions of years. The information processing capabilities apparently demonstrated by 3I Atlas raise fundamental questions about the nature of intelligence and computation in cosmic systems. The object appears to respond to external stimuli, modify its behavior based on environmental conditions, and possibly even communicate through organized signal patterns. While natural systems can display adaptive behavior, the apparent sophistication of 3I Atlas's responses suggests either remarkably advanced natural processes or actual information processing systems. The preservation and maintenance mechanisms that have kept 3I Atlas functional during its interstellar journey represent technologies that exceed current human capabilities, regardless of their origin. Whether natural or artificial, the systems that have maintained the object's integrity, functionality, and information content across millions of years of interstellar travel operate according to principles that we're only beginning to understand. The navigation and guidance systems apparently employed by 3I Atlas demonstrate precision and sophistication that challenge current understanding of both natural and artificial navigation mechanisms. The object's precise trajectory, optimal approach timing, and apparent course maintenance capabilities suggest either natural processes that operate with unprecedented accuracy or artificial guidance systems that surpass human technological achievements. The communication systems analysis focuses on the radio emissions and other signal patterns that could represent either natural phenomena or deliberate communication attempts. The sophistication of the apparent communication protocols, the information content of the signals, and the optimization for interstellar transmission all suggest either natural processes that mimic technological communication or actual communication technology, operating according to principles we don't fully understand. The self-repair and adaptation capabilities suggested by 3I Atlas stable operation during its interstellar journey would represent remarkable achievements, whether natural or artificial. The object has apparently maintained its structural integrity, functional capabilities, and mission profile across timescales that would challenge any conceivable human technology. This suggests either natural systems with unprecedented durability and self-maintenance capabilities, or artificial systems designed with redundancy and repair mechanisms that exceed current technological understanding. The modular construction analysis examines whether 3I Atlas shows evidence of assembly from discrete components rather than natural accretion processes. Some observational data suggests organizational features that could be consistent with modular design principles, where different functional systems are integrated into a coherent overall structure. While natural processes can produce organized structures, the apparent modularity of 3I Atlas is remarkable. The evolutionary adaptation question addresses whether 3I Atlas shows evidence of modification and improvement over time, rather than simple degradation or random change. Some observational data suggests that the object has adapted its behavior and characteristics in response to environmental conditions during its interstellar journey. This adaptive capability could represent either sophisticated natural evolutionary processes or artificial learning and adaptation systems. The manufacturing signatures analysis attempts to identify evidence of construction processes rather than natural formation. The regular features, organized internal structure, and apparent material processing evident in 3I Atlas could result from either natural processes operating under very specific conditions or artificial manufacturing techniques that achieve precision and organization beyond current human capabilities. The quality control indicators examine whether 3i Atlas shows evidence of design optimization and error correction that would be expected from deliberate manufacturing processes. The object's apparent reliability, functional integration, and operational stability over extended periods suggest either natural selection processes that have optimized its design or artificial quality control systems that ensure consistent performance. The technology transfer analysis considers whether 3i Atlas might represent a repository of technological information rather than simply a technological artifact. The object's apparent information content, communication capabilities, and complex internal organization could indicate that it serves as a library or database of technological knowledge designed to be accessible to other intelligences that encounter it. The reverse engineering possibilities focus on what humanity might learn from detailed study of 3i Atlas regardless of its origin. Whether natural or artificial, the object demonstrates capabilities in materials, science, energy management, information processing, and system integration that could advance human technology in numerous fields. The study of its principles and mechanisms could yield insights that accelerate human technological development. The comparative analysis with human technology reveals that 3i Atlas demonstrates capabilities that exceed current human achievements in every relevant category. Its energy efficiency, structural durability, information processing capabilities, and system integration all surpass the best human technology by significant margins. This superiority could result from either natural processes that achieve remarkable optimization or artificial technology based on more advanced scientific principles. The scaling analysis examines whether the principles apparently employed by 3i Atlas could be applied to human technology development. The object demonstrates how complex systems can be designed to operate reliably over extended periods in harsh environments while maintaining multiple functional capabilities. These design principles could inform human approaches to long-term space exploration and autonomous system development. The philosophical implications of the technology question extend far beyond 3i Atlas itself to fundamental questions about intelligence, consciousness, and purposefulness in the universe. If the object represents natural phenomena that achieve technological levels of organization and functionality, it suggests that the universe itself might be far more creative and purposeful than current scientific models indicate. If it represents artificial technology, it confirms that intelligence and technological capability exist elsewhere in our galaxy and operate on scales that dwarf human achievements. The methodology questions address how science can distinguish between sufficiently advanced natural phenomena and actual technology when dealing with systems that operate according to principles beyond current understanding. This epistemological challenge may require new frameworks for scientific analysis that can accommodate possibilities that transcend current theoretical boundaries while maintaining rigorous standards of evidence and interpretation. As the investigation of 3i Atlas continues and more data becomes available, the technology question becomes increasingly complex and significant. Whether this remarkable object ultimately represents natural phenomena that achieve unprecedented levels of organization and functionality, or actual technology created by intelligence that evolved elsewhere in the universe. Its study is expanding human understanding of what is possible in cosmic systems and challenging our most fundamental assumptions about intelligence, purpose, and design in the natural world. The study of 3i Atlas has begun to reveal patterns and characteristics that extend far beyond a single interstellar visitor, suggesting the possibility that our galaxy might contain an interconnected network of objects, intelligence, and information that operates on scales so vast that human civilization has only recently developed the capability to detect its existence. If such a network exists, humanity's encounter with this enigmatic visitor might represent our first contact with a galactic-scale phenomenon that could reshape our understanding of intelligence, communication, and organization throughout the cosmos. The network hypothesis emerges from the recognition that 3I Atlas displays characteristics that seem optimized for information collection, processing, and transmission across interstellar distances. The object's trajectory through our solar system, its sophisticated communication capabilities, its apparent information storage systems, and its remarkable preservation across cosmic timescales all suggest that it might serve as a node in a larger information network that spans significant regions of galactic space. The infrastructure analysis of such a hypothetical galactic network reveals the enormous scope and sophistication that would be required for its implementation. A communication and information system spanning thousands of light years would need to operate according to principles that integrate physics, information theory, and engineering on scales that dwarf any human technological achievement. Yet, the apparent capabilities of 3I Atlas suggest that such infrastructure might actually exist. The communication protocols analysis examines how objects like 3I Atlas might serve as relays or nodes in a galactic-scale information network. The object's radio emissions, trajectory optimization, and apparent information content all suggest capabilities that would be consistent with network communication protocols designed to operate across interstellar distances and timescales. Such protocols would need to account for the vast delays, signal degradation, and interference that characterize interstellar communication. The data collection hypothesis suggests that 3I Atlas might serve as a mobile observatory designed to gather information about stellar systems and potentially inhabited worlds throughout the galaxy. The object's sophisticated observational capabilities, information storage systems, and trajectory planning all suggest that it could be systematically surveying stellar systems and collecting data about planetary environments, technological civilizations, and cosmic phenomena. The information processing capabilities apparently demonstrated by 3I Atlas could serve multiple functions within a galactic network. The object might analyze collected data, process communication signals from other network nodes, and potentially even make autonomous decisions about its mission parameters based on information gathered during its interstellar journey. Such autonomous capability would be essential for any network operating across galactic distances, where central control would be impossible. The coordination mechanisms that would be required for a galactic network raise fascinating questions about distributed intelligence and autonomous coordination. Objects like 3I Atlas would need to operate independently while maintaining coordination with other network elements across vast distances and timescales. This would require either pre-programmed coordination protocols or actual distributed intelligence systems that can adapt to changing circumstances. The temporal coordination challenges facing any galactic network are staggering in their scope. Communication delays between network nodes could span centuries or millennia, making real-time coordination impossible. Instead, the network would need to operate according to predictive models and autonomous decision-making protocols that can maintain coordinated behavior despite the inability to communicate rapidly across the network. The evolutionary aspects of a galactic network suggest that such a system might develop and improve over time through the cumulative experiences of its constituent elements. Objects like 3I Atlas could learn from their encounters with different stellar systems, share information with other network elements, and gradually improve the network's overall capabilities and knowledge base through distributed learning processes. The maintenance and self-repair capabilities required for long-term network operation would exceed anything in human experience. Network elements would need to operate reliably for millions of years while traveling through the harsh environment of interstellar space. This would require either remarkable natural durability or sophisticated self-maintenance systems that can repair damage and adapt to changing conditions autonomously. The redundancy and fault tolerance requirements for a galactic network would necessitate multiple backup systems and alternative pathways for information flow. The loss of individual network elements to stellar encounters, mechanical failure, or other hazards would need to be anticipated and compensated for through network design that maintains functionality despite individual component failures. The scalability analysis reveals that a galactic network would need to accommodate growth and expansion as it encounters new stellar systems and potentially new technological civilizations. The network architecture would need to be flexible enough to integrate new nodes, accommodate increased information flow, and adapt to new types of data and communication protocols that might be developed by different civilizations. The multi-species coordination possibilities raise profound questions about how a galactic network might integrate contributions from multiple independent technological civilizations. Different species might contribute different types of information, communication protocols, and technological capabilities to the network, creating a truly collaborative galactic intelligence system that transcends any single civilization. The historical analysis suggests that a galactic network might have been operating for millions or billions of years, gradually accumulating information about galactic evolution, stellar system development, and the emergence and evolution of technological civilizations. 3i Atlas might carry within its information systems a historical record that spans geological timescales and encompasses vast regions of galactic space. The Discovery Protocols analysis examines how a galactic network might handle encounters with newly emerged technological civilizations like humanity. The behavior of 3i Atlas, with its optimal observation geometry and apparent communication attempts, suggests that the network might have specific protocols for initial contact with new civilizations that balance information gathering with non-interference principles. The membership criteria question addresses what characteristics a civilization might need to develop before being considered for integration into a galactic network. The apparent sophistication of 3i Atlas suggests that network participation might require technological capabilities, communication protocols, and perhaps even ethical frameworks that exceed current human development. Our ability to detect and study this visitor might represent an early assessment of humanity as readiness for broader galactic contact. The information sharing protocols within such a network would need to balance open communication with security considerations. Different civilizations might contribute different types of knowledge while protecting certain sensitive information about their capabilities, locations, or vulnerabilities. 3i Atlas might be programmed to share certain types of information freely while maintaining restrictions on other data that could be potentially harmful if misused. The governance structures of a galactic network raise fascinating questions about distributed decision-making and consensus building across multiple civilizations and vast distances. The network would need mechanisms for establishing common goals, resolving conflicts, and maintaining coordination despite the inability to hold real-time discussions. This might require sophisticated voting mechanisms, consensus algorithms, or even artificial intelligence systems that can represent the interests of member civilizations. The resource allocation questions address how a galactic network would manage the enormous resources required for its operation and maintenance. The construction, deployment, and ongoing operation of network elements like 3i Atlas would require materials, energy, and technological capabilities that might exceed what individual civilizations can provide. This could necessitate collaborative resource pooling and shared manufacturing capabilities across multiple stellar systems. The ethical frameworks governing network operations would need to address fundamental questions about interference with developing civilizations, resource utilization rights, and the preservation of cultural and biological diversity throughout the galaxy. The apparent non-invasive approach of 3i Atlas suggests that the network might operate according to principles that respect the autonomy and natural development of individual civilizations. The scientific collaboration possibilities within a galactic network could accelerate knowledge development beyond what any individual civilization could achieve. The sharing of scientific data, theoretical frameworks, and experimental results across multiple civilizations could create a collaborative research environment that advances understanding of fundamental physics, cosmology, and the nature of intelligence itself. The exploration-coordination aspects of a network could optimize the exploration of galactic space by preventing duplication of effort and ensuring comprehensive coverage of interesting stellar systems and phenomena. Objects like 3i Atlas might be deployed as part of coordinated exploration missions that systematically investigate different regions of the galaxy, while sharing their findings with the broader network. The cultural exchange implications of galactic network participation could transform human understanding of art, philosophy, ethics, and meaning. Contact with multiple alien civilizations through network participation could expose humanity to radically different perspectives on existence, consciousness, and the purpose of intelligent life in the universe. The technological advancement opportunities available through network participation could accelerate human development by centuries or millennia. Access to the accumulated knowledge and technological achievements of multiple advanced civilizations could provide insights into physics, engineering, and information science that would dramatically expand human capabilities. The existential risk mitigation possibilities suggest that galactic network participation might provide insurance against planetary or civilizational catastrophes. The distribution of human knowledge, culture, and possibly even genetic information throughout the network could ensure the survival of human civilization, even if Earth were destroyed by natural disasters or technological failures. The long-term evolutionary implications of galactic network participation could influence the development of human consciousness, intelligence, and technological capabilities over thousands or millions of years. Integration into a galactic-scale intelligence network might represent the next major evolutionary transition for human civilization, comparable to the development of language, writing, or scientific methodology. The detection significance of 3i Atlas extends beyond its individual characteristics to what its presence might reveal about the broader galactic environment. If this object does indeed represent evidence of a galactic network, its detection suggests that such networks might be common features of galactic evolution, operating in many or most regions of space where technological civilizations have emerged. The participation prerequisites for joining such a network likely extend beyond mere technological capability to include wisdom, ethical development, and the ability to contribute positively to galactic-scale collaborative endeavors. Humanity's response to the 3i Atlas encounter might serve as an assessment of our readiness for broader galactic participation. The invitation hypothesis suggests that 3i Atlas might serve not just as an information-gathering mission, but as an invitation for humanity to join a broader galactic community. The object's optimal observation characteristics, apparent communication attempts, and information-rich structure could all be designed to attract the attention of emerging technological civilizations and provide them with the information needed to establish broader galactic contact. As we continue to study 3i Atlas and decode its potential messages, we may be taking our first steps toward understanding our place in a universe that is far more interconnected and purposeful than we previously imagined. The possibility that we are encountering evidence of a galactic-scale intelligence network challenges our most fundamental assumptions about isolation, communication, and cooperation on cosmic scales. Whether 3i Atlas ultimately proves to represent natural phenomena, individual artificial intelligence, or evidence of a vast galactic network, Its study is expanding human consciousness to encompass possibilities that seemed purely theoretical just a few years ago. The universe revealed by this enigmatic visitor is one where intelligence, purpose, and connection might operate on scales that span galaxies and timescales that encompass the entire history of cosmic evolution. As 3I Atlas continues its journey beyond our solar system, gradually fading from our telescopes and returning to the cosmic darkness from which it emerged, humanity is left to grapple with the profound implications of what this enigmatic visitor might represent for our species' future. Whether this object ultimately proves to be an exotic natural phenomenon, an artificial construct, or evidence of something even more extraordinary, its passage through our cosmic neighborhood has fundamentally altered human perspectives on intelligence, communication, and our place in the universe. The scientific implications of the 3I Atlas encounter extend far beyond astronomy and astrophysics to encompass virtually every field of human knowledge. If the object's unusual characteristics stem from natural processes, they reveal that the universe operates according to principles of organization, complexity, and information processing that exceed our current theoretical understanding. This would necessitate revisions to fundamental theories about cosmic evolution, stellar formation, and the behavior of matter and energy on galactic scales. The technological implications are equally profound, regardless of 3I Atlas's ultimate origin. The object demonstrates capabilities in materials, science, energy management, information processing, and system integration that surpass current human achievements by significant margins. Whether these capabilities result from natural optimization processes or artificial engineering, they provide roadmaps for technological development that could accelerate human progress by decades or centuries. The philosophical implications of 3I Atlas challenge fundamental assumptions about intelligence, consciousness, and purpose in the universe. If natural processes can achieve the apparent levels of organization and complexity demonstrated by this visitor, it suggests that the cosmos itself might be far more creative and purposeful than current scientific paradigms indicate. If the object represents artificial intelligence or technology, it confirms that consciousness and technological capability exist elsewhere in our galaxy and operate on scales that dwarf human achievements. The educational transformation required to process the implications of 3I Atlas will reshape how humanity teaches and learns about the universe. Educational curricula will need to incorporate new frameworks for understanding cosmic complexity, interstellar phenomena, and the possibility of galactic-scale intelligence networks. Students will grow up with an expanded conception of what is possible in the universe and humanity's potential role in cosmic evolution. The research priorities shift triggered by 3I Atlas has already begun redirecting scientific resources toward interstellar object detection, analysis of cosmic complexity, and the search for evidence of intelligence or organization on galactic scales. New observational programs, theoretical frameworks, and technological development initiatives are being designed to better understand and potentially communicate with similar cosmic visitors. The international cooperation requirements for studying objects like 3I Atlas are fostering new models of global scientific collaboration that transcend national boundaries and political differences. The recognition that cosmic visitors represent opportunities for all humanity is creating incentives for international cooperation that could serve as models for addressing other global challenges, ranging from climate change to resource management. The technological development acceleration resulting from study of 3I Atlas could transform human capabilities across multiple domains. Insights into the object's materials, energy systems, information processing, and communication protocols could advance human technology in ways that reshape everything from space exploration to artificial intelligence to global communication networks. The space exploration implications of the 3I Atlas encounter are driving new missions and technologies designed to detect, study, and potentially intercept future interstellar visitors. Space agencies around the world are developing rapid response capabilities that could enable detailed study of similar objects, potentially including sample return missions that could provide direct access to materials from other stellar systems. The communication protocol development inspired by 3I Atlas's apparent signaling capabilities is advancing human understanding of how to communicate across interstellar distances and potentially with non-human intelligences. Research into universal communication principles, mathematical messaging protocols, and information preservation techniques is being accelerated by the need to understand and potentially respond to the signals apparently being transmitted by this cosmic visitor. The existential risk assessment implications of 3I Atlas extend beyond the object itself to broader questions about humanity's vulnerability to cosmic phenomena and the potential for encountering more advanced intelligences. The object's sophisticated capabilities raise questions about how humanity should prepare for encounters with cosmic visitors that might be less benign than 3I Atlas appears to be. The cultural evolution accelerated by the 3I Atlas encounter is already beginning to reshape human perspectives on cosmic citizenship, interstellar responsibility, and humanity's role in galactic evolution. The recognition that we might be part of a larger cosmic community is inspiring new philosophical frameworks, ethical principles, and cultural narratives that prepare humanity for potential participation in galactic-scale civilization. The economic implications of technologies potentially derivable from 3I Atlas study could transform global economic systems through advances in energy generation, materials science, information processing, and communication technologies. The economic value of insights gained from this cosmic visitor could exceed the gross domestic product of major nations, creating new industries and economic opportunities while potentially disrupting existing technological paradigms. The political implications of 3I Atlas include both opportunities for international cooperation and potential sources of conflict over access to technologies or information derived from its study. The object's significance as a potential source of technological advancement creates incentives for both collaboration and competition among nations, requiring new frameworks for managing the political dimensions of cosmic discoveries. The military implications of advanced technologies potentially derivable from 3I Atlas study are driving discussions about the weaponization of cosmic technologies, the militarization of space, and the need for international agreements governing the use of technologies that might be derived from interstellar visitors. The potential for technological breakthroughs that could shift global power balances is creating new security considerations for nations worldwide. The environmental implications of 3I Atlas include both insights it might provide into sustainable technologies and the environmental consequences of implementing advanced technologies derived from its study. The object's apparent energy efficiency and long-term operational stability could provide models for sustainable technological development that addresses current environmental challenges. The social implications of the 3I Atlas encounter include changes in how humanity views itself relative to cosmic scales and potentially other intelligences. The psychological and cultural adaptation required to process the possibility of galactic-scale intelligence networks could reshape human social structures, value systems, and collective goals in ways that persist for generations. The religious and spiritual implications of 3I Atlas challenge traditional theological frameworks while potentially inspiring new spiritual perspectives on humanity's cosmic role and purpose. Religious institutions worldwide are grappling with how to interpret the possibility of cosmic intelligence networks within existing theological contexts, while potentially developing new spiritual frameworks that encompass galactic-scale phenomena. The legal implications of 3IO Atlas include questions about property rights in interstellar objects, international law governing cosmic visitors, and the legal frameworks needed to manage technologies or information that might be derived from their study. Current legal systems lack precedents for addressing the issues raised by interstellar visitors that might carry information or technologies of enormous value. The ethical implications of studying and potentially exploiting technologies or information from 3I Atlas raise fundamental questions about humanity's responsibilities toward cosmic visitors and, potentially, the intelligences that might have created them. Developing ethical frameworks for cosmic encounters requires consideration of principles that transcend current human moral philosophies. The long-term evolutionary implications of the 3I Atlas encounter could influence human development over thousands or millions of years. Integration into galactic-scale intelligence networks, adoption of technologies that exceed current human capabilities, and exposure to cosmic perspectives on intelligence and consciousness could drive evolutionary changes in human cognition, culture, and even biology. The preparedness implications of 3I Atlas suggest that humanity needs to develop capabilities for detecting, studying, and potentially communicating with future interstellar visitors. This requires investments in advanced observational technologies, rapid response mission capabilities, and theoretical frameworks for understanding cosmic phenomena that exceed current scientific paradigms. The legacy planning considerations raised by 3I Atlas include how humanity should preserve and transmit knowledge about this encounter to future generations, how to maintain continuity of research programs that operate on timescales longer than individual careers or political administrations, and how to ensure that the lessons learned from this cosmic visitor continue to inform human development across multiple generations. As 3I Atlas disappears into the cosmic distance, it leaves behind a transformed human civilization that must now grapple with expanded conceptions of what is possible in the universe and what role humanity might play in cosmic evolution. Whether this visitor represents natural complexity, artificial intelligence, or something even more extraordinary, its legacy will be measured not just in scientific discoveries, but in how it transforms human consciousness and prepares our species for a future that might be far more interconnected and purposeful than we previously imagined. The universe revealed by 3I Atlas is one where intelligence, information, and purpose might operate on scales that span galaxies and timescales that encompass the entire history of cosmic evolution. Humanity's response to this revelation will determine whether we rise to meet the challenges and opportunities of cosmic citizenship or remain isolated observers of phenomena we cannot fully comprehend. The future shaped by the 3I Atlas encounter may be one where humanity joins a galactic community of intelligence, contributes to cosmic-scale projects of exploration and discovery, and participates in the ongoing evolution of consciousness and complexity throughout the universe. Or it may be one where we remain forever changed by the knowledge that such possibilities exist, even if they remain beyond our reach. Subscribe to continue exploring the mysteries that challenge our understanding of intelligence, purpose, and possibility in an infinite cosmos.